All right, on-site wastewater treatment is going to be the focus of this video, and some folks may actually, in this class, end up working for a local or state health department. And our local and state health departments have a lot of responsibilities as it relates to on-site waste treatment, particularly septic systems, as well as some alternative designs to septic systems. With municipal wastewater plants, the big ones, they are often regulated through a state division of water or state division of surface water, through often the energy and natural resources type committees or the EPA through the state agency related to the EPA. On-site treatment systems are often regulated by the health departments or the local health authorities in those states. So on-site wastewater treatment, the most common example consists of like a pipe going from the home out to a septic system or septic tank to start with, then maybe going to a distribution box, and then going out into the soil distribution system or the drain field or the leach field or whatever term you want to call it. And then the soil underneath of this drain field will do the work of actually cleaning up the wastewater effluent. The sludge will be collected here, mostly in the septic tank. So we're going to discuss kind of when we should use septic systems, how they function, how we should maintain them, and how health departments will do the inspections. So again, why do we treat sewage? Because we know there's always somebody downstream, and the Clean Water Act says that we want our nation's waters to be swimmable and fishable. We can't have a bunch of failing wastewater treatment plants and a bunch of failing septic systems or no on-site treatment discharging sewage to our nation's rivers, streams, and lakes. And we also know that our drinking water is downstream of even somebody's septic tank. So on-site treatment systems are particularly useful for suburban and rural areas where we may lack that core mass to have a community-wide city sewer system. The distance to the city sewer might be too far, so it might cost a homeowner or the community way too much money to run that many miles of sewer pipe, as well as overcoming the topography. So would you have to install lift pumps, and those require energy. So an on-site treatment system may be the best option. And the purpose of the wastewater treatment on site is to deliver wastewater to the soil from the septic tank so that the water is acceptable before the wastewater joins either the groundwater or the surface water. And we know that the contaminants from particularly human waste pose risk to human and environmental health. And the job of the soil is to remove the contaminants using natural, physical, chemical, and biological processes that are already present in healthy soil. And soil, unlike dirt, soil is a living system. So on-site waste treatment options include cesspools, and I wouldn't call this a latrine a treatment option, but a way of storing the waste until it can be treated. Then there are septic systems and other systems that are out there. And these systems are designed for when you have 20 or less people on one system. So in order to have a septic system that works properly, we need to have soil that is appropriately permeable. If the soil is really like clay rich and it's hard for water to go down into it and the water just stands on it, then it might be too slow. We also can't have just pure sand. Water can't just run right through the soil or run through the sand and go too fast. Also, we don't want water, and sometimes too slow and too saturated go together. We don't want where water is standing on the surface. We don't want to try to treat our wastewater in a milieu of other water. So we can't be like putting this out into a wetland or to a marshy area. And the soil scientists and many of the public health professionals who are scientists recommend we have at least 4 feet of suitable soil. Now, in some parts of the United States, it's harder to achieve that. In some states, don't require 4 feet. They have provisionally suitable designations for properties that do not have 4 feet of suitable soil. But the soil scientists and many others recommend at least 4 vertical feet of high quality soil for these purposes. How do we assess whether or not soil is acceptable? So soil surveys can be performed using hand texturing as well as percolation tests. And hand texturing, if you've ever had a soil class or maybe in elementary school or middle school, you take some soil and then you rub the soil between your thumb and your finger. And if it ribbons out, then you know it's clay. If it breaks down really quickly, then it might have too much sand in it. And a mixture of that in between might be some clay loam or silt loam. So there's a variety of ways to assess that. There's percolation test, where you can actually have a known amount of soil. The water goes into the top of the soil, and how long does it take before it gets to the bottom of the soil, or it comes out as water? That tells you the percolation rate of the soil. There are instruments now that do this. One is called a lysimeter. So I'll see about pulling up a picture of how a lysimeter works. Okay, so here's an image of a lysimeter in action. And this is just one. There are a variety of different types that are out there. And soil scientists and environmental engineers are more familiar with using these. And rather than waiting for how long it might take, which could be hours for the water to go down through the soil to a known distance, you can use pressure and force everything down through the system, and then know how much of your water you get back and be able to tell, the quality of the soil that way. And part of the reason why that might be of interest is because you want to speed things up, and the lysimeter, based on the pressure, can help you understand a little more quickly how things move through the soil. So I'm going to just stop there on this part and move on to how to interpret the results, because that's the more important part. So if you're constructing a leach field or constructing that soil distribution system, so if you remember at the beginning here, you need a place for the water to go down into the ground. The percolation rate, if it's too slow, it's going to just not go down and it just kind of stick there or go up to the surface. We don't want that. So if the percolation rate is really, really fast, so if it can go 5 minutes per inch, so if you add water to the top and within 5 minutes that water travels 1 inch vertically down, that's the fastest rate that's allowed in Kentucky. So that's like really sandy soil, but you can still think it takes 5 minutes for the water to go down 1 inch. And then this is the slowest rate, probably more clay soil, where it takes it an hour and a half for the water to go down just 1 inch. So you could imagine if you had 3 feet, you could do 36 inches times 90 minutes. I mean, you're looking at 2,700 minutes just to get the water to even go 30 inches down. So this is very slow. 5 minutes per inch is not very fast actually, but compared to soil speaking, it's actually quite fast. So we need optimal amounts of time. If you are going to take 90 minutes for the water to go down 1 inch, you're obviously going to need to spread that water out over a greater area. So you're going to need to run more trench so that you can accommodate the wastewater coming out of the house. It has to be able to go somewhere. And if it can't go down fast enough because it's taking 90 minutes to just go a single inch, then you're going to need more trench space. You're going to need to use more of your yard or more of your field or your area for running trench lines. If it's really fast, you don't need to use as much yard area. Some would argue that this may be not as ideal for disinfection by the actual natural soil microbes, but that's the law. So, all right, how is the soil assessment done? So in many cases, there's like a county soil survey book. Every county in the United States has got one. The U.S. Department of Agriculture and the Soil Conservation Service, both, they kind of have access to those resources. Libraries have them. I think all the soil survey books are online now. The person doing the soil assessment needs to look to see if there's any landscape features that may prohibit the soil from doing an effective job for wastewater treatment. There's a metal probe that can be pushed down into the ground where you're going to just check to see if there's any like hard pan or rocks that are going to prohibit the soil from doing the right job. If you hit a hard impermeable layer that doesn't allow the soil to go down more than 4 feet or 3 feet before it hits that hard layer, that might indicate a problem. It may also, or likely, will excavate or grab some soil samples to see what the profile of the soil looks like, and then they'll match the soil resource up to whatever the appropriate septic treatment system is possible. Now, when they're looking at the soil, a limiting layer of bedrock, so if there is at the base a rocky layer, so if you've got soil and then you probe and go down and you hit hard pan, like a hard rock layer, and there's soil on top of it, that water usually can go down, but then it can only go out or up. It gets trapped. And if it stays trapped there, especially in like clay soil, you may see this mottling, this this kind of rust-looking coloration, especially if there's iron in there. So that indicates that there's been a seasonal high water table where it's high a lot of the year. That's a problem. We need our wastewater to be able to be treated year-round. So we're going to get into why that's important here in a few minutes. But the first thing we have to cover is how a septic tank functions. So the water comes into a pipe, and this should not be like that way. It should actually be a continuous pipe that goes down. So the inlet comes in, and then the liquid that is here, heavy stuff will sink as sludge. Fats, oils, and greases will go up. And if you have an outlet baffle over here on this end, the outlet baffle will be down here where the water can come in and out. But the scum, or the fats, oils, and greases, will be trapped here. It's really important that we trap the fats, oils, and greases in that layer and don't let it, if it comes in, if it comes in on this side, like in that video or in that image, we want the sludge to go down and the fats, oils, and greases to rise up really quick and get trapped in the middle. We don't want the fats, oils, and greases going out into our soil distribution system, out into the outlet. Fats, oils, and greases will plug up the permeable pipe that we've got out there. And I'll show you a picture. Usually in class I've got the image to show you of what that pipe looks like. Go into a distribution box that will then route it into usually a series of a couple or 3 or 4 pipes. These pipes have little holes in them, like those, or a lot of finer perforations. These are just, you can see some examples. There's an example here of some gravellous leach field pipe. There's a lot of fine little holes in these that allow the water to leak out of it and goes into the soil. If you have fats, oils, and greases as they kind of run out slowly across that pipe, you know what fats, oils, and greases do to like sinks and things is that stuff gets a little bit warmer, or not warmer, but a little bit cooler at times of the year, or just even at room temperature, it will harden and it will plug those pipes up. And if they get plugged up with fats, oils, and greases, you're going to have to dig your yard up and replace these. So we don't want to short circuit our outlet and our distribution system by not capturing the scum that comes in here. So we're going to get more into this here in the next few slides. So septic tanks often are either this heavy-duty, high-density plastic, HDPE plastic, or concrete. You see 2 inspection ports on the top. We're going to watch a video now on how these septic tanks are inspected, and you probably learn a little bit from it.